Hello, 8th grade, and here's another podcast. This one is going to be on more algebra, on expanding and simplifying. Okay, so let's take a look what we mean by this. In this first question, it's asking us to find the expression for the area of the rectangle. Okay, well, those of you that haven't done any geometry since last year, remember that the area is always length times width. Okay, well, let's deal with this first. Okay, so this is the width of 2 and the length of x, so 2 times x. This is 2x. And for this rectangle here, this is 2 and this is 4, so it's going to be 8. So it looks like our area is 2x plus 8. Okay, well, what's the point of this? Well, let's think about it as this way. What if we take a look at the whole length together? Okay, so this is x plus 4 and this is 2. Okay, well, then the area is going to be 2 times x plus 4, right? Because it's still length times width. Okay, well, what do we get then? Well, look, this is, when it's outside the bracket, is multiplication, okay? So 2 times x is going to give us 2x. Now, the 2 is also multiplying the 4. Okay, so that's how we get the same answer. So the point is, when you have this expansion, you need to distribute the 2 to every term inside the brackets. Okay, so this is called the distributive property. So it's the property when you apply what's outside the bracket to every term inside the bracket. Okay, so now we're going to try a couple of examples. So this is 3 times x. Okay, well, remember that x times x, just going to put it on the side here, is x squared. Okay, it's not 2x. It's a very common mistake that the students make. X plus x is 2x. Remember from the last podcast, dollar plus a dollar, $2. But when you have x times x, this is the equivalent of saying 4 times 4. And of course, we know that this is 4 squared, right, which is 16. Okay, so 3x times x. So this is going to give us 3. The 3 just stays, x squared. And now we need to expand. We need to distribute the 3x. 3 times 5 is going to give us 15. And the x. Okay, that's x right there. Now, what you see is that they're not like terms, so you cannot collect them together, so you're finished. Okay, let's try this. Okay, this is a little bit trickier. Okay, 3 times 2, that's 6. But how do we do f squared times f cubed? Well, if you put f to the power of 6, that would be wrong. And let's see why. Well, we can break f squared into f times f. And we can rewrite f cubed as f times f times f. When you multiply these together, and hopefully everybody's okay with me using a dot for multiplication, you have 1, 2, 3, 4, 5 f's. So you have f to the power of 5. So you may remember this rule, or you've seen it somewhere, that when you're multiplying the variables, you're going to end up adding the exponents. Now this is 3 and this is 4. That makes 12, and then there's no f's, so f squared. Now, you can put together f to the power of 5 and f to the power of 2. Remember from the last podcast, if the powers are different, they are not like terms. So you are finished. All right, let's do 2 more here. This one, it's not more difficult, it's just written differently. So you're still going to distribute, but you're just going to distribute this way, okay? So 7q times r squared. So we've got 7. We could write q r squared or r squared q. Always go alphabetically, okay? So OPQR, so Q R squared plus 12 R squared. So we've distributed the R squared. These terms are not alike, because remember, having 7 of these guys is different from having 12 of these guys, because these are QR squareds and these are just R squareds. Okay, now this one I chose because this is a very common mistake. So why don't you pause this right now and just try to do this problem. Okay, now unpause. And I'm guessing that a lot of you have written this. No. Okay, why not? Give yourself a second to think about it. You can pause it again. But this right here, remember what I said before, if it's just outside the bracket like this is multiplication, right? Which means that you're going to have to follow the order of operation. So first we're going to multiply this out. So we have 5 minus, now 2 times x is of course 2x. Now this is also tricky because this is a negative and a negative. And a negative times a negative is going to be positive 6, because that's 2 times 3. Okay, now identify your like terms. 5 can go with 6, so we're going to put 11 minus 2x. And hopefully you've done this on your own before you've listened to me do it, because that's really a much better way to learn. Okay, so that's your introduction to expanding terms, and now you can go ahead and try the work.